Everyone, welcome to this tutorial on the introduction to computer programming. If you've ever wondered how your favorite apps, websites or video games are created, you're in the right place. In this tutorial video, we're going to demystify the world of programming. Don't worry if you're a complete beginner, all you need to know is what a computer is. So let's dive in. First off, a computer is a general purpose machine which can perform many computational tasks. And the modern day computers that we have can do billions or trillions of calculations within a fraction of a second. These computers can't really understand anything on their own. They are as good as dumb. And so for a computer to do something, one has to give it instructions to do. These instructions must contain step-by-step information on how to perform a specific task. This step-by-step set of instructions is what is known as a program. The person who is going to write these instructions, or rather the person who is going to write the program, is known as the programmer. So the programmer will write the programs and the computer will work on the instructions given to it. That is, the computer will execute the program. Just in case you haven't fully gotten the picture, let's use the analogy of food to understand what programming really is. Imagine you're a chef and you have a recipe to follow. The recipe tells you step by step what to do. Chop the onions, salt them, add tomatoes, and so on. Programming is similar. It's about giving your computer a recipe or a set of instructions to follow. These instructions could be to add numbers, store information, or even play a game. The language in which these instructions are written, or rather the language in which this program is written, is known as a programming language. Now, there are several different types of programming languages available, and nowadays so many new programming languages have been created. So let's talk about the types of programming languages. The first type of programming language is machine language, or what we call low-level language. It consists of binary code that directly communicates with the computer's hardware. Binary code is simply code that is written in a sequence of zeros and ones. Each instruction is represented by the zeros and the ones. But the problem with this machine level language is that in order to program in it, one has to know everything about the computer, because here the programmer is interacting directly with the computer hardware and memory. So one has to know about the computer architecture, the computer processor, everything about that needs to be known. And this is why machine language is extremely difficult for humans to read and write directly. Let's take for instance, you've written many lines of code and writing them itself was difficult in the first place. And if it happens that you made several mistakes in the written code, it will be difficult to spot the errors. To solve this problem, another type of programming language known as assembly language was created. In the assembly language, mnemonic codes were introduced. Mnemonic codes are used to represent machine-level instructions. Assembly language is more human-readable than machine language. It uses symbols and mnemonics to represent operations and memory addresses. Let's say a programmer wants to write code that adds 5 and 6. In machine language, assuming the opcode for addition is represented by the binary sequence 1, 0, 1, 0, and memory locations for the numbers 5 and 6 are represented as 0, 0, 1, 0 and 0, 0, 1, 1 respectively. The binary code for adding 5 and 6 might look like this: 1, 0, 1, 0 representing the opcode for addition, followed by the opcode for 5, which is 0, 0, 1, 0, and then the opcode for 6, which is 0, 0, 1, 1. But in assembly language, you just write add 5, 6. Then the challenge again in programming using assembly language is that the written program cannot be directly translated into machine code that the computer will understand. There is need to convert the assembly code into machine code. To do so, a program called assembler is used. It takes basic instructions and converts them into a pattern of bits that a computer's processor can use. So here the machine language and assembly language are known as low-level languages, because when a programmer writes programs using one of the two, the programmer directly interacts with the computer memory and data. Even though writing programs in assembly language seemed easier than writing in machine language, assembly language also has similar drawbacks, especially when the programs become larger and making it difficult to spot errors. So to solve this, high-level languages were created. High-level languages were created in such a way that they were human-readable and easy for a beginner in programming to learn. For instance, to add 10 plus 3, you just need to write 10, the plus sign, and 3. Just by looking at it, anyone can understand. It's because of this that many people started learning how to write programs. Now the thing is, the programs written in high-level languages cannot be directly translated into machine code that the computer's hardware can understand, and so there's need to convert the program written in a high-level language into machine code again. Examples of high-level languages may include Python, Java, C++, Kotlin, and many others. So to understand how high-level languages work, it's crucial to understand how they are converted into machine code that a computer can execute. There are two primary methods for this conversion. There's what we call compilation and what we call interpretation. Compilation is a process where the entire high-level program is translated into machine code before execution. A special program called a compiler reads the high-level program, checks it for errors, and translates it into an executable machine code file. Once compiled, this file can run on the computer without needing the source code or the compiler. For instance, programs written in C are compiled into machine code using a compiler like GCC. Once compiled, the machine code can be executed directly by the computer. In the same way, C++ programs are compiled into machine code before execution. Go, which is a language developed by Google, also uses a compiler to translate Go programs into machine code. Now, there are benefits of compilation, and one of them includes speed, as compiled programs generally run faster than interpreted ones because the translation happens once and the machine code is executed directly by the hardware. Compilers can optimize the code, making the executable more efficient. In addition, once compiled, the program can run on any computer with a compatible operating system without needing the source code. Interpretation, on the other hand, is a process where the high-level program is translated into machine code line by line at runtime. An interpreter reads each line of the high-level program, translates it into machine code, and immediately executes it. This means that the source code is required each time the programs run. For example, Python programs are executed by the Python interpreter, which translates and runs the code line by line. JavaScript code is interpreted by web browsers, allowing for dynamic execution within web pages. Ruby also uses an interpreter to execute code directly. The benefits of interpretation include flexibility, as interpreted languages are often more flexible and easier to debug because the code is executed line by line. Interpreted programs can run on any platform with the appropriate interpreter installed, enhancing portability. In addition, rapid development and testing are possible since changes can be tested immediately without recompilation. Mid-level languages, often referred to as intermediate-level languages, bridge the gap between high-level and low-level languages. They provide a balance of readability and control over hardware, combining the benefits of both. Examples of mid-level languages include C and C++. While primarily considered as high-level language, C allows for low-level memory manipulation, making it suitable for system programming. C++, on the other hand, extends C with object-oriented features but retains low-level capabilities. That is why C and C++ fall between mid-level languages. The characteristics of mid-level languages include efficiency, as they can produce efficient machine code, similar to low-level languages. They offer more control over hardware and memory management compared to high-level languages, and they are more readable than low-level languages, making them accessible to more programmers. Alright, we've covered a lot of ground in this introduction to programming. from understanding what programming is and the different types of programming languages, to diving into compilation and interpretation. Each concept is a stepping stone to becoming a proficient programmer. So keep learning and happy coding.